ball. So now though, what we really want to do is study the gravitational potential energy and kinetic energy of this ball. So we will create two more expressions, one for gravitational potential energy and the other for kinetic. We will push F3 to toggle off the preview graph, and now we need to define gravitational potential energy, or as we will abbreviate it, GPE. So let's move the cursor down to the next line in the calculator and type in G, P, and E equals M, which is the mass of the ball, times G times H. And then we will push the check mark. And when we do, you see that the Explorer GLX needs us to tell it what M and G are. Notice that it doesn't ask what H is. We've already defined it in the line above. So we predetermined the basketball to be 0.52 kilograms. So I will type that in, 0.52. Check. And gravity will use 9.8. Check. Okay, so now we've defined our gravitational potential energy, so we can go on to kinetic energy, or KE. Okay, equals 0.5 times, and we'll use M again, times V. And notice that there is no button on the keypad that will let us square the velocity. Take a look in the functions menu by pushing the F1 button, and notice here that there are a number of expressions and constants that we can use in our expression. And if you look down on that third row there, the caret 2, which is the standard convention to square our values. So we'll push the check mark to select that one, and now we've got velocity squared. Push the check mark to tell the Explorer GLX that we are done with that expression, and it comes back and asks us what V is. Again, notice it didn't ask us what M is. We defined it above. V is data, is the velocity that we obtained from the motion sensor. So again, we go to our F2 button, which reveals our data sources, and select velocity, item 2 on that menu. Okay, push the check mark, and on the bottom left corner of the GLX screen it says calculation is okay. So we are done with this. Let's go back to the graph display and take a look at what this looks like in a graph. So we will go home and back. Now, we don't want to lose this data here. We like these graphs. So what we want to do instead is create an entirely new graph page. So we can keep this graph page. Look at your graphs menu, F4, and item 6 there lets you create a new graph page. And we get one of position versus time. What we want to see on our graph page is gravitational potential energy and kinetic energy, so two measurements on the same graph. Go back to our graphs menu where we hopefully remember that item number 3 there lets us see two measurements. And now we're looking at position and velocity, but we know how to change the data sources on our y-axis, and we do that by pushing the check mark to activate our hotspots. Push the check mark again to select one, and take a look at our data sources there. There's all the calculations, all the expressions that we defined in the calculator. So the one we want here is our gravitational potential energy. So we will select it. And let's go to the other side, push the check mark, use the arrow key to move to our other y-axis, check mark, to select that one. And on this axis we want kinetic energy. Select it. And if we scale it, because of the spikes there, it won't auto scale. So if we push F2, that will allow us to manually scale our axes. But notice a couple things. Our graph display is missing some important items that you would expect your students to use when they're creating graphs, and that is the units for your y-axis labels. So let's go back to our hotspots, select the data property for each of those y-axis measurements, and then add the units to it. Push the check mark. Push the check mark again because we want to select gravitational potential energy. And the last item there, whoops, let's go down back to 8. Data properties. We want this to be joules, J. Oops, push the check mark to select it, J. O. U, L, E, and S. F1 for OK. Now I want to show you something here. Take a look at the axes on this. Notice that for the gravitational potential energy, the scale goes from 0 to 8 joules. And for our kinetic energy, our scale goes from 0 to 300 joules. What we want to do is make sure that our units are aligned for both of those axes. One way that you can ensure that is to make sure that you have the same units on both sides of your graph. So let's go to our kinetic energy measurement and change the data properties for that so that it includes the units. We're stuck there. Whoops, we were just there. Push the check mark to select it and select data properties for kinetic energy. And also for this one, we will type in joules. I sure hope you're faster at finding the letters on the keyboard than I am. Okay, check mark, and OK. Now you see that the axes are the same. We've got them both going from 0 to 300. Let's scale it by pushing the F2, and we can use the arrow keys to stretch that up just a bit and over a bit. And now we can see by looking at our gravitational potential energy, which starts up, and the kinetic energy, which starts down, that there seems to be some sort of exchange in energy. Well, we have a challenge for you. What would our graph look like if we looked at the sum of gravitational potential energy and kinetic energy? So we've already created a number of expressions using the calculator. We're going to challenge you to go pause the video for a moment and actually see if you can figure that out yourself. When you think you have it done, come back. We'll be waiting for you with the answer. So how'd you do? Here's our results. Do yours look anything like that? To get them, we used this equation. Now, we put this in a new graph page so we can preserve our other pages, and you see that we have some here on our y-axis, and we also included the units. This represents the sum of gravitational potential energy plus kinetic energy. Okay, now after doing all this work, we would like to preserve it, and there are two ways that we can do this. One is by saving our file, and the other is by printing our graphs. So let me show you both of those. Starting with saving, we need to go back to the data files screen. So we'll back out by going to our home screen and then push the check mark because our data file screen is selected already. And now we can save from here. You see the F2 button, that lets us save it. But first of all, let's give this file a title so we can remember it. Push the check mark so that we can edit it. And I'm just going to call this BB short for bouncing ball. Also makes typing it in really quick. Okay, and once we've done that, push the check mark to finish our edit, and then finally push the F2 button to save the file. And now it's saved. Okay, let's go back to our graphs menu using our shortcut. And we're going to print this. Now, if you have a compatible HP printer, like we happen to have right here, you can connect it to the USB port on the right side of your xploer GLX. And then look in your graphs menu yet again, F4. And you see the last menu, numbered menu item on there. Sorry, it's actually 7 and 8. You have two choices. One is print, the other is print all. If you select print, you will get a page that reflects the graph page that you currently have on your screen. If you select print all, it will print one per page, each of the graphs that you have created. So we will go back to our graphs menu and select item number 7. Let me get this out of the way. Print, which will print our sum page. And you can see that it's going to be waiting here for a minute after we push F1 to print. This is going to take a few minutes, so we're going to take a time out while it prints. All right, here is our graph. It's lovely. We've got some of our two energies against time, and it's labeled also with the experiment name. Now, let's take a minute to evaluate it. You can see that the sum of gravitational potential energy and kinetic energy is relatively constant, and as expected, between bounces, we see a little bit of loss of energy due to friction. My question to you, as we leave, is can you explain what this sudden dip in energy is between each of the bounces?